All right, IBAISL2 kids. Today we are finishing off Chapter 6. It was kind of a short chapter. It's really just about regression in general, and correlation. Today we're just going to talk about a couple examples of interpreting a regression line. I've showed you how to find a regression line by using lin-reg on your TI calculator, but now we're going to talk about what it would mean in the context of a real-world problem. So for each example, you're going to state the value of the gradient. Now, if you're like, what is that word? I haven't seen that much. It's going to happen a lot more in an IB curriculum because this is their British word for slope. So from here on out, if it says gradient, just think slope. So we're going to look at the slopes and the y-intercepts of regression lines and interpret their meaning in the context of the problem. The first problem, they did a survey of a bunch of students in high school about how many hours per week they spend on social media and how many hours of sleep they are getting per week. They ran the data, they came up with a regression line. It turns out there was high correlation, and this was their regression line. So, first of all, X is hours spent on social media, and Y is the hours of sleep that they get per week, or they're both per week. The first thing I think when I look at this is I almost want to rewrite this in my brain as y equals negative 2x plus 50. Because this is in the more familiar like y equals mx plus b style. Now the gradient is right here. This means that the gradient, which is the slope, remember, is negative 2 over 1. Now remember that a slope or a gradient is rise over run, or it's change in y over change in x. Or it's, like y2 minus y1 over x2 minus x1 if you have two coordinates and you're trying to find it. What this means, since y is the sleep and x is the hours on social media, the interpretation of this right here, well, first of all, it's negative. So negative correlation implies that the more hours spent on social media, the less sleep, because of the negative slope. Now the negative 2 over 1, remember that the top is the y and the bottom is the x. So this is negative 2 sleep for 1 social media. So my interpretation of that is that for every hour spent on social media, students get 2 hours less sleep per week. So that was me interpreting the gradient, negative 2 over 1, but now we need to interpret the y-intercept. Now the y-intercept is 50. That's when you make x 0, you get a y of 50. Now remember, x is social media and y is sleep. So the y-intercept is 0, 50. But what this means, the interpretation within the context of the problem, is that 0 hours on social media is 50 hours of sleep. So I think this implies if you were to cut out social media altogether, that you would be getting 50 hours of sleep per week. And then if any hours spent on social media is just going to decrease that number. So it's going to be, for every hour on social media, that number is going to go down by 2, based on the data, based on the regression line. Last example, Someone studied the hand length of 5 to 8-year-old boys for some reason. X is the age in years, and Y is the hand length in centimeters. So first up, the X is the age in years. I'm assuming that an X equal to 0 would imply 5 years old. Because they said that the study was all of boys that are 5 to 8 years old, then the X equals 0 has to line up with 5. Now, the regression line. Remember that the gradient is right here. So the gradient, it's already in the y equals mx plus b. We don't have to reorganize it, but the gradient is 1.7 over 1. It's kind of an awkward thing with the decimals like that. So let's move the decimals over a little bit and say this is like, well, no, that's not going to make more sense. Yeah, let's leave it like that. Just think of 1.7 over 1. Now, remember that this is change in y over change in x. The y was the hand length, and the x is the age. So this is 1.7 centimeter hand length all over 1 year of age. So to interpret the slope, I would say, first of all, it's positive, which means when age goes up, the hand length also goes up. And in specific, from the 1.7 over 1, we would say for every year a boy ages, they get 1.7 centimeters more hand length. The y-intercept is 1.5. So we'll just say that the y-int is 0, 1.5. I would interpret this as, because it was 5 to 8-year-old boys, when time is 0, that implies a 5-year-old. So I think this means 5-year-olds on average, in this study at least, have 1.5 centimeter hand length. All right, you guys, that's about all I got. And that's it for the chapter. So next class, we'll review.